Hello students, welcome back to MathFace Java programming tutorials. In this video, I'll explain binary search on integer array. Let's see the contents. Introduction, dry run of the program on integers. Case 1, case 2, case 3 and case 4 we will see to understand the algorithm. There are two types of searches. First one is linear search, second one is binary search. Linear search, we know already. It starts searching from index 0 to last index. If the input size is 1 million, then the element is not found 1 million times. It searches and then decides. Now, linear search is used when lesser number of elements are there in the array. Third and fourth, very important, duplicates are allowed in the array in case of linear search. And array elements need not be sorted. But in case of binary search, duplicates are not allowed in the array and array elements need to be sorted. Now let's see the logic of linear search. For loop, if, and whatever we want to do, count, found, whatever. Outside the for loop, we display either count or found or not. In linear search, we use 5 variables. First one is array itself. Second one is SRC, that is search element. Third one, length of the array. Fourth one, some counter variable to run the loop, that is J0, J less than n, J plus plus. And counter found to store. But in case of binary search, we need 6 variables. The array, for example, employee or emp array in this case, search element, which is SRC, position, that is pause to store the index, and initially -1, lower bound, upper bound, LB to store 0 index initially, UB to store size -1, and mid to store the middle index. And the entire algorithm is depending on LB, UB, mid only. If at all search element is present in the array, it is found at mid index only. Mid index only, that means emp of mid. Mid index, mid element. Now the search algorithm is like this. Read array and search element first of all. Initialize LB and UB variables, 0 and size -1. We start a loop as long as lower bound less than equivalent to upper bound, the loop should work. Every time we calculate mid element, that is LB plus UB divided by 2. We'll understand one by one. Don't worry. Then if, else if, else. So inside the loop, mid calculation, one if, then second else if, then else ladder. We find whether SRC equals to mid element or not. First if statement. If it is true, position is updated, okay, found, and break. Else if that is not equal to, then SRC, the search element, is less than mid or not. If it is lesser, then our UB will be mid -1. Very important. Search space is divided into half, 1/4, 1/8, like that. Else means not equivalent to, that is fifth part, SRC is not equal to mid element. SRC is not less than mid. That means SRC is greater than middle element. In that case, our lower bound will be transferred to mid +1 index. And go back to step 3. What is it? First of all, read array, then initialize LB, UB, loop, you take LB less than equal to UB. Every time calculate mid, if, else if, else. Okay, let's understand more about this. Here is the program, but in the program we will understand only the red colored statements in the slide. Okay, emp is the array where employee numbers are there 1, 3, 8, 10, 15, 16, 92, and 100. No duplicates, and it is sorted. Fine. Let me read the program. SRC is the element to be found. Emp is the array. LB is 0, UB is 7. Why? Because there are total 8 elements. So, length minus 1. Now, position not found minus 1. Why? Because our index starts from 0. Minus 1 means initially not found. And mid. This mid will be calculated inside the while loop. Now, while LB less than equal to UB, mid is equal to LB plus UB divided by 2. What is LB initially? 0. UB is 7. 0 plus 7 divided by 2 is 2 3s are 6. We take the quotient. And if at all our SRC, that is search element, is equivalent to emp of mid, that is element, not index. Mid is index. Emp of mid, in our case 3, mid is 3. Emp of mid, that is 10. So SRC is 10, position is mid break. Else if, we are actually trying to understand else if and else in this. Else if SRC, that is search element, is less than emp of mid, mid is still 3. Emp of mid means 10. SRC is less than 10. If at all search element is less than 10, our new UB would be, upper bound would be, because we have to search till 1, 3, 8 only in the array, because it is less than 10. So our upper bound would be mid minus 1. Mid is 3. Upper bound, new upper bound would be 2. That means LB is 0 only, but upper bound is 2. That means half of the array we have eliminated. Binary search. Else. Else means greater. That means mid element is 10. Please see the array. If user gives input, that is search element, is greater than 10, then it goes to else part. Now, LB will be shifted, not UB. LB will be mid plus 1. Mid is 3, mid plus 1 is 4. That means new LB would be 4, but UB will be 7 only. Either one of the cases, if, else ladder. Lesson number 16. I have made you understand this if, else, if ladder. Now, so from 4 to 7 only it will search. So binary we are dividing into half. Again, 1/4, 1/8, and so on and so forth. But we see a practice exercise 1 over here. Is binary search possible in the following arrays or not? If not, why? Int x square brackets is equal to 4, 5, 7, 5. Duplicate elements are there, so not possible. Now int square brackets z. See, x square brackets or square brackets z. Anyway, we can declare and initialize. 2, 4, 7, 8, 5 are the elements. These are not sorted. If not sorted, binary search is not possible. String days, not sorted. Char grades, not sorted, as well as duplicates are there. So in these four types of arrays, binary search is not possible. Now, let's understand this particular algorithm with the help of four search cases. Search element is 10. That is mid element only because our array size is 8. 0 plus 7 divided by 2 is 3. Every time we run the program. Search element at mid element only, first time only. Search element is 8. That means less than mid element. Search element is 16. That is greater than mid element. 700 not found in the array. We will understand with the help of these four. Case 1 search element is 10. Here we have program left side, right side dry run. Please look at the LB, UB after each iteration and pause also. Now SRC is 10. Search element is 10 and employee is the array. Initially, right side, please look at the LB is 0, UB is 7, that is emp dot length minus 1. Program and dry run we see simultaneously. And position is minus 1. While LB less than equal to UB, LB is 0, UB is 7, true. So, in the dry run, first iteration, true, LB less than equal to UB. Then immediately we need to calculate mid. Mid is equal to LB plus UB divided by 2. That is 0 plus 7 divided by 2 is 3. First time. Now, if SRC is 10, equals to employee of mid. Just mid is 3. Employee of mid is 10. And SRC is equivalent to 10. Employee mid is equal to 10. So, position is equal to mid because it is true. This is true. Position is mid, that is 3, and break, come out of the loop. So found at mid element only for the first time only. So this while loop worked only once. Okay. Now let's go back to the second search element, that is 8. In this, 3 iterations are required. In linear search also, 3 iterations. But as the size grows, number of iterations in binary search drastically comes down. How? Let's see. Then search element is 8. In this case, LB is 0, UB is 7, and position is minus 1. And we are reading the program and seeing the dry run simultaneously. While LB less than equal to UB, right side if you see 0 less than equivalent to 7, true, first iteration. And mid would be calculated every time inside the while loop. 0 plus 7 divided by 2 is first time 3 only because input size is 8. If SRC, that is 8, equivalent to emp of mid, mid is 3, emp of mid is 10, false. Then else if SRC less than emp of mid, see the right side. SRC less than emp of mid is true. Why? Because SRC is 8, emp of mid is 10. So, else if part is true, then UB is equal to mid minus 1. Search space divided into half. RUB becomes 2. Now, second iteration. Is LB less than equal to UB? 0 less than equal to 2. True. Second iteration. Then 0 plus 2 divided by 2, that is 1, that is mid. Emp of mid, that is 1 means 3. Emp of 1 is 3. And we are searching for 8. Is it equivalent? False. And next statement, else if SRC less than M puff mid. M puff mid is 3. SRC is not less because we are searching for 8. It is greater than. So it goes to else and says LB is equal to mid plus 1. Current mid is 1. Mid plus 1 is 2. So LB becomes 2. See, LB becomes 2. Third iteration. LB less than or equivalent to UB. Yes, 2 less than or equivalent to UB. So mid would be 2 plus 2 divided by 2. That is equal to 2 only. So mid is 2 and we are searching if again. If SRC double equals to M puff mid. SRC is 8. M puff mid is 2. M puff mid is 8. Yes, true. Then pause is equal to mid. Pause is 2 and then break. Pause is 2 and then break. So position became 2. If you see outside the while loop, if position not equal to -1, print found. Yes, our position is not -1 found. But we are trying to understand inside the while loop only. Now let's see the third case. In this case, search element is 16. LB is 0, UB is 7, position is -1. While LB less than equal to UB, 0 less than equal to 7, true. Only 2 iterations in this case. Let's see. First time true. Mid is LB plus UB divided by 2. That is 0 plus 7 divided by 2 equals to 3. Every time we run the program, because the search space is 8, it becomes 3 only. Now, first time SRC equals to M puff mid. First if SRC is 16, mid is 3, M puff mid is 10. Is it true? False. Else if SRC less than M puff mid. R16 is not less than 10. So automatically it goes to else part and LB is equal to mid plus 1. Mid is 3 initially, mid plus 1 is 4. So LB is changed to 4. Second iteration, LB less than equal to UB or not. 4 less than equivalent to 7, true. In that case, mid is 4 plus 7 divided by 2, that is equal to 5. Fine. First if statement, SRC, that is 16, is equivalent to M puff mid or not. Mid is 5 now. M puff mid is 16. SRC is 16 and M puff mid is 16 in the array. So position is equal to mid. Position is 5 and then break. So this is the third one. Fourth one is 700, which is not there in the array. Initially 0 and 7. See here 4 iterations and it is finding the 700. The search element is not there in the array. Had it been linear search, requires 8 iterations. Fine. While LB less than equal to UB, true 0 less than equal to 7, then mid is 0 plus 7 divided by 2, that is 3. Is SRC equivalent to M puff mid? 700 is not M puff mid and it is not less than. So goes to LB is equal to mid plus 1, that is 4. LB becomes 4. Fine. Second iteration, is 4 less than 7 or not, less than or equivalent to? True. 4 plus 7 divided by 2 is 5. Is it equivalent to? No. Is it less than? No. Then LB is equal to mid plus 1. That is, current mid is 5. 5 plus 1 is 6. So in the second iteration, our LB becomes 6. Then third iteration, 6 plus 7 divided by 2, because LB is less than or equivalent to UB. So 6 plus 7 divided by 2 is 6 only. Is it equivalent to? False. Is SRC less than? False. LB is equal to mid plus 1. That is, 6 plus 1 is 7. So our LB became 7. Then while loop, is LB less than equal to UB? Yes, equivalent to. Then mid is 7 plus 7 divided by 2, that is equal to 7 only. 7 means that is 100, it is pointing at. M of 7 is 100. Our search element is 700. Is it equivalent to? False. Is it less than? False. So LB is equal to mid plus 1. Mid is 7. 7 plus 1 is 8. So our LB became 8. Now the while loop becomes false. Why? Because LB is not less than equivalent to UB. So position is minus 1 only. False comes out of the loop. If position is minus 1, print not found. This is the 700 case. Now the time complexity of the algorithm is O log n. If the input size is 1024, maximum 10 iterations, 10 times it searches. If input size is 16 lakh, maximum 20 iterations. The binary search algorithm is very powerful. Only 20 maximum 20 iterations to search the entire 16 lakh elements in the array. Had it been linear search, if the element is not found, 16 lakh times it will traverse through the array and then decides whether found or not. And you can visit this https wikipedia.org for time complexity, understanding time complexity. And then link is given in the description box. Practice exercise 2. Dry run of the following search elements in the following array using binary search algorithm. Please do dry run so that you understand more about the program. And we'll see Java program over here. Then practice exercise 3 we will see. Now class binary int. Int m is the array. All elements are sorted 1, 3, 5, 7, 9, 10, some numbers. Search is the method which is receiving a search element. LB is 0, UB is m dot length minus 1, pause minus 1, mid, while LB less than equal to UB, mid is equal to LB plus UB divided by 2. If at all SRC is equal to m of mid, then pause is mid break. Else if SRC less than m of mid, UB is equal to mid minus 1. And then search space went from half, divided every time half, 1/4, 1/8, and so on and so forth. If pause minus 1 not found, else found at pause plus 1. Because for the computer, index starts at 0, but for human beings, the number is 1, first element, not 0th element. So pause plus 1, position plus 1 for human beings. And void main, we've created an, because both of them are instance variable and instance method, created an object b1.search 9 or 3, 15, 18, 0, anything. 18 is not there in the array, 0 is not there, but we will execute 9, 3, 15, and 0 now. Okay, let's execute this program and see. Control A. First time we are trying to search 9. It is found. Found at 5. Let's see, is it at 5 only? 1, 2, 3, 4, 5, because we said pause plus 1. Had it been 3, is found at 2 control K and execute main. Okay, found at 2 second position, and so on and so forth. Okay, let's see practice exercise 3. Read an array of 5 grades, that is characters, in a sorted order in read method and search element in search method. Find the element using binary search. Declare the array and the length as instance variables. Call the methods in main method. And second one, initialize, not reading, in the main method. And call linear search and binary search. And search elements are given over here. Link to practice exercise 2 and practice exercise 3 given in the description box. Refer Chapter 7 of Essentials of Computer Applications for further understanding and practice exercises. And the next video is on binary search on strings. It is a separate topic. Why? Because double equals to and less than operators can be used on characters, floating point numbers, and integers, but not on strings. So we will understand string binary search in the next video. Thank you.